So we are back with Unit 1. So we're looking at CP Physics Unit 1, math tools. And what we're going to look at today is error and percent error. Now, what we're really talking about when we talk about error and percent error is just how off are you on a measurement. Let's say that it is a known fact that there are 5 dots on the screen now. It's a known fact. But if I say, take a quick glance and count them, and you go, boom, and you're like, 6. Well, you would have measured 6 dots. There is a generally accepted, for everybody who's taking their time and counting this, value of 5 dots. That means you have some error with your measurement versus the accepted value. Okay? Now, for counting like this, like there is an exact thing, but for measurements, because we could have, those estimated digits, like maybe 18.7 something, because there's these estimated digits, we may not be exactly on the true proper value or what people have accepted as being the true proper value, because most of the accepted values for things are what scientists have taken many repeated experiments done, and they're averaged answers together. Okay, so how does your measurement go against what, as science determines, is the statistical average and then accepted answer to this problem? And the way we do this is with an error and percent error calculation. For an error calculation, it is simply the measured minus the accepted. So for our little example here, it would simply be 6 minus 5, and you would get an error of 1. Okay, and technically, because we're counting dots, it would be like 1 dot is your error. The positive, it being a positive 1, represents that our measurement was larger than the accepted value. If we would have only measured 4 instead, then our error would be -1, and that would represent that we are less than the accepted value. So your errors can be positive or negative. It just represents, are you greater with a positive, or are you less with a negative than the accepted value? Find a percent error is just taking the error itself, whatever you calculated here, and then dividing it by the accepted value. And the percent error is normally for us a little bit more useful than the error itself. The percent error gives us a better idea of how close were we in the scheme of the actual accepted answer. For instance, let's say if there were dots on the screen and we counted for our measurement as 10,114, and the accepted value was 10,115. Well, our error here would still be 1, just as it was before. But if we look at the percent error, we find vastly different different percentages. If we look at our percent error from the previous example with just 5 dots, our error is 1, and we divide it by the accepted value of 5, we find that this value is 0.2, and to turn it into a percent error, we multiply it by 100. This turns it into a percent. So multiplying it by 100, moving the decimal place to the right twice, 1, 2, would be equivalent to a 20%. You were off by 20%. Okay. Over here, when we do the same thing, our percent error is 1 divided by 10,115. This is a very small number. 1 divided by 10,115 is, it's going to be it's 9.8 times 10 to the minus 5. So that's 1 and then 4, so then boom. So it's really going to be 0.00, what was that? 1 and then 4, bring it back 2. 0.0098%, right? So it's a very different percent error. Even though your error values are off by the same 1 dot, because there's so many more dots here, your percentage is very close. You're way closer in respect to hitting that 10,115 than you are to the 5. Okay, so percent errors are what we use a little bit more often. They give you a better idea of if you are closer, even if your value is very large, very strange, versus having a very small value and just being off by 1. So that's just something to think about there when we're doing errors and percentages, percent errors throughout some of this unit. Okay, but that's pretty much it. Error is just a measured minus accepted. It can be positive or negative. Percent error is error divided by the accepted, multiply it by 100 to get it into a percentage, just like you've always done in your math classes. And with that, this is finished. Take it easy.